graphing linear inequalities in two variables. So I think back in 10 we did some stuff with the number line, right? You say y is greater than or equal to 3, you put a solid dot on the 3 and you draw an arrow to the right. Y is less than or equal to -5, you know, same deal, you put a solid dot on the -5 and draw a line. But what do we do in two variables? So we've learned how to graph linear equations in two variables by slope and y-intercept, or the x and the y-intercepts, right? So the first step is we're going to have to draw this thing, right? We have to graph this, and then from there we'll figure out, well, what do we need to do? What is this whole inequality stuff? So use the slope and y-intercept to sketch the graph of 2x minus 3y is equal to 12. So slope and y-intercept means we have to rewrite it in the form y equals. Okay, so how do we want to do that? Well, so we need y equals mx plus b, right? This is the slope. This is the y-intercept. Okay, you don't have to write that down when you're solving stuff, right? I'm just reminding you that's the form we want. Okay, we got 2x minus 3y is equal to 12. So negative 3y is negative 2x plus 12. So we have to isolate the y. And now, to really isolate the y, we're going to divide everything by what? Negative 3. This will become y is equal to 2/3 x minus 4. Right? When we divide everything, that is everything on the right-hand side, when we divide it by a negative, we're changing its sign, right? So it becomes negative 2x becomes positive 2/3 x, and positive 12 becomes negative 4. Okay, and we are to use that to sketch the graph. So y equals 2/3 x minus 4. Let's do this guy in red. So I've got minus 4. I'm going to plot the y-intercept, then 2/3 says go up 2, right 3, go up 2, right 3, and it also says go down 2 and left 3. Because I want to get as many points as I can, right? The more points I have, then they should all line up. I should be able to draw a nice straight line. Okay, I put arrows on the line, so I've got as many points as I can fit on the grid. I put arrows on the line to indicate this goes on forever. And I can write the equation of the line down there so we can see, okay, that's which line that is, right? Because we're graphing two lines. Use the x and y intercepts to sketch the graph of 3x plus 4y equals 12. Okay, so I need x and y intercepts. It's only going to give me 2 points, right? But how many points does it take to draw a straight line? 2. Okay, that's all we need. Okay, so x-intercept. What do we do to get the x-intercept? We set y equal to 0. Okay, so let's write it out. 3x plus 4 times 0 plus 12, sorry, yeah. Plus 12 equals 0. 3x equals negative 12. X is negative 4. Okay, so now I've got the x-intercept, right? I know that the x, we will intercept the x-axis at negative 4. The y value is 0. We're going to use green here. How do I get the y-intercept? We set x equal to 0. So 3 times 0 plus 4y plus 12 equals 0. 4y is negative 12. Y is equal to negative 3. And put this back, so the y value is negative 3. And then here's the line I want to draw, right? I'm going to be a little more accurate, so 1, 2, 3, 1, 2, 3, 1, 2, 3. going to throw another little point on there, right? Now you guys will have a ruler probably, or a straight edge or something, so it'll make it easier for you to graph. And let's label that 3x plus 4y plus 12 equals 0. Okay, questions? Concerns? Comments? Okay, scroll that down a bit. Use some clues in here. You also, you kind of know from this, right? If I do intercepts on this one, if I set y to 0, x will be 6. If I set x to 0, y will be -4. So there's 6, there's -10. Matches up, it's good. Okay. I kind of know on this guy, if I move it over, it'll be 4y equals -3x, so the slope will be -4. There'd be a negative slope, if nothing else, right? So I've got a negative slope there. Extend your lines through the grid. Okay, so I don't want to see this one being drawn like this. Okay, so don't do that, right? Control Z worthy. Okay, so don't do that. Extend your line through the entire grid. Show as many points as you can. I actually, kind of counted here just to get that one point, but that's all you really need. Okay. Now, I was just drawing a line, right? So what is this linear inequality? So the equation of a line can be expressed. Let's go express. It can be expressed by the linear equation ax plus by equals c. If we replace the equal sign with the symbol less than, greater than, less than or equal to, or greater than or equal to, then a linear inequality is formed. A linear inequality may be expressed in one of the following four forms. Ax plus by is less than c. Ax plus by is greater than c. Ax plus by is less than or equal to c, less than or equal to, and this one greater than or equal to. Where a, b, and c are real numbers. Okay. Pretty much we aim for a, b, and c to be integers and a to be greater than 0, right? So we get a positive x. Okay. It's always good to lead off. You don't want to have an equation like -5x. Well, not necessarily, but when it's written in this form, right, which is a standard form. The graph of the line ax plus by equals c, really any straight line, divides the coordinate plane into regions, one above the line and one below the line, right? For one of the regions, the statement ax plus by is less than c is true, and for the other region, the statement ax plus by is greater than c is true, right? So that means we could take a point, any point that's not on the line, it's either going to be true for this, it'll be, this will make a true statement, or that'll make a true statement. The set of points that satisfy a linear inequality can be called the solution set or solution region, right? Because really, it's a half of the plane. Below is the graph of the line y equals 2x minus 3. In the table is a list of points that are either on the line, above the line, or below the line. Complete the table. Okay, so here's what I mean. Let's do this. Where's the point 2, 1? Well, there's the point 2, 1. Is it on, above, or below? It's on the line. So if I'm going to put a statement in there, what am I going to say? 1 equals. Okay, so we're filling in with it's either equal, which means it's on the line. All right, so let's do the next one. -3, -1. That point is here. So where is it? It's
-1. Oh, just
I'm pretty fragile, and making me doubt myself. So where is it? It's above. Okay, you guys are here for here when I really mess up, right? It's all right. Call me out, right? I mean, you know. So if it's above, then what are we going to say about -1? Is it equal to this? Is it greater than this? Or is it less than? It's going to be greater than, right? Because it's above the line. Above the line means that your y, the y value we're getting is greater than, right? Because what's the y value? It's like -9, right? So the point that's on the line is -3, -9. -1 is above that, right? It's bigger, you know, it's above. Whatever. 5, -6. Where is that?
It's below.
Are we looking at the same line?
I have the entire thing built up, so I read the wrong one.
Okay. So where is it? Below. So what do we say about -6? It's got to be less than. Okay, I shall pause. You shall fill in the remainder. Okay, so is that good? And by good, I mean it's correct and always right with the world, and we're, you know, the sun is not really shining. But hey, it's not that cold though. Use your findings from the table to complete the following sentences with one of the following statements. Okay, so we've got y is equal to mx plus b, y is less than mx plus b, y is greater than. If the point xy lies on the line y equals mx plus b, then the point satisfies the statement y is equal to. If the point, blah, 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 lies above, then the statement satisfied is, yeah, then the y value must be greater than, right? It's above. And by process elimination, the only thing that could possibly go, plus it makes sense, right, is y is less than. Now, that's the easy way to do it, right? Because the equation, you know, 2x plus 3y equals 12, and you say stuff about it, and it's like, well, okay, then I'm going to have to go look at some points to figure out whether they are or they aren't, right? Whereas when it's in the form y equals mx plus b, then I know immediately, give me a point, oh, it's above or it's below, right? Like, which region is above? All right, in other words, all the points that satisfy the inequality y is greater than mx plus b lie above, and all the points that satisfy the inequality y is less than lie below. Okay, remember, any point you have questions, ask questions. Graph 2x plus 3y is less than or equal to 6 using the slope and y-intercept. Okay, so here's what we got to do. We must find where it's equal, right? We need the line. What the heck am I looking at? Oh. Right, so we're going to graph y equals, right? We can graph that. So we're going to graph y equals. So step 1, graph it as y equals, because I want the line, right? We can do that. We don't have to worry about the less than, greater than stuff. Okay, so what are we starting with? 2x plus 3y equals 6. 3y equals negative 2x plus 6. Y equals negative 2/3 x plus 2. Okay, so all we do is we just solve the equation, right? Just get in the form y equals. So that's the line that I want to graph. It's the boundary, right? It's the one line that's going to split it into two regions. Okay, so let's do that. Negative 2/3 x plus 2. Negative 2/3 x plus 2. There's a 2. Negative 2/3. 2. Go down 2, right? 3. And also go up and to the left. And up and to the left. Okay? It's not like as many points. If I've done this right, they should all lie on a straight line. Now, here's the thing. The boundary line. It's either part of the solution or it isn't. What would make the boundary line part of the solution? If it says
less than or equal to.
less than or equal to or greater than or equal to, then we know, oh, you're including the line, right? When you say equal to, that includes the line. To do that, we're going to draw a solid line. Okay? And this is supposed to be, right, greater than or equal to, sorry, what is it? It's less than or equal to, right? Okay, so draw the line and draw it as a solid line. Extend it through the entire grid and put arrows on there, right? Now, if this had been, which it really is, it's a less than or equal to, would we have done any fiddling with it? You know, would we have divided both sides by a negative or multiplied both sides by a negative to cause it to flip around? And the answer is no, right? If that had been, it's okay, we subtracted 2, that's fine. We're dividing by positive 3. Okay. So this is going to stay really as y is less than or equal to negative 2/3 x plus 2, right? Okay, but wait a second, is there another way to test this, right? Well, what we could do is take a test point. Okay, so let's try a test point. And the test point we're going to use is 0, 0, right? 0, 0 is a great test point, okay? Because it makes life easy to substitute. Okay, so go back up here. We say test point 0, 0. Is 0, 0 going to make this true? So 2 times 0 plus 3 times 0 is less than or equal to 6. 0 is less than or equal to 6. True or false?
True.
True. Which means that the point 0, 0 is in the region, which means that we are going to shade below, right? We want to shade so that which means we really are graphing y is less than or equal to this, right? So I'm going to shade this below. And I want to shade the whole grid.
What is shading?
Shading indicates the solution region. So shading says any point down there is going to make this true. Okay? Because ultimately we're supposed to graph that, right? We're supposed to graph 2x plus 3y is less than or equal to 6. Okay? So we did it slope-intercept to get the line. We said it's less than or equal to, which means that the line is part of the region, it's part of the solution. Okay? We graphed the boundary line and we made it solid because we say, hey, this is part of the region. We then tested a point. Okay, let's try 0, 0. Okay, yeah, that works. Okay? So we could have said, you know, you can do this as well. You go like 2x plus 3y is less than or equal to 6. 3y is less than or equal to negative 2x plus 6. Y is less than or equal to negative 2/3 x plus 2, right? So I could do it with the inequality. I generally don't like it. I like to do the boundary line and just do it as an equals, and then maybe use a test point to figure it out. But you could do it with the less than or equal to. We could do all the rearrangement, do all the algebra, and just say, okay, if y is less than or equal to, that means it has to be below, right? Y is less than or equal to. So when you're in the form y equals greater than or equal to, less than or equal to, greater than, less than, you know which region to shade, right? When it's in the form y something mx plus b, you know which way to go. In this case, down. Doing a test point is just a double check. Should 0, 0 be in the shaded area? Yes, it should. Okay, which way should I be shading this? Should be shading below. Graph 2x minus 3y is less than or equal to 6 using the slope and y-intercept. Okay, so 2x minus 3y. 2x minus 3y. So we're going to work with the boundary line, right? So we're going to work with 2x minus 3y is equal to 6. Actually, you know what? Yeah, let's do this. Let's go. 2x minus 3y let's work with the inequality, right? So we'll deal with the inequality. 2x minus 3y less than or equal to 6. Okay, so negative 3y is less than or equal to negative 2x plus 6. Okay, now what's going to happen when I go and divide by negative 3? We got to reverse the inequality, right? So it becomes y, and this changes to greater than or equal to 2/3 x minus 2. We're still dividing by the negative, right? So negative divided by negative is positive, and positive divided by negative is negative. So we've got y is greater than or equal to. We need to now graph the boundary line. So we're going to graph y equals 2/3 x minus 2 as, okay, as a solid line or as a dotted line?
Solid.
As a solid line because it's part of the solution. As a solid line. And then what does this say? Where should we be shading? Shade above. Okay, so do this in green. What is it? 2/3 x minus 2. 2/3 x minus 2. There's the minus 2. 2/3 go up 2, right 3. Go up 2, right 3. Go down 2, left 1, 2, 1. God, can't count. Go down 2, left 3. Yeah. This counting stuff. The thing is, and the reason I draw all the points is if you miscount, your line's going to go like this and then take a turn, right? And you say, wait a second, I'm supposed to be graphing a straight line. Like, I might have messed something up. Okay, extend this out. You don't need to label the line because it's the only line we're drawing, right? If we're doing more than one on a grid, then we would label the lines, right? And it would say graph and label each line. Okay. And what do we say? We were shading where? Above. Okay, so shade above. You can actually shade, right? Like you got pencils and stuff. So it's harder for me to shade, so I can sort of draw this. Okay. You can actually draw these on your calculator, like they'll shade it for you, right? There's a greater than or equal to symbol in the calculator that you can use so that you can, oh wait a sec. No, okay, you can't graph that, but you can tell it which way to graph. Well, really, if we're telling it to graph above, then that's kind of redundant anyway. So, like we didn't let the calculator do stuff for us. But let's use the test point 0, 0. Right? Because I think 0, 0 is going to make this true. Okay? So test 0, 0. 2 times 0 minus 3 times 0 is less than or equal to 6. 0 is less than or equal to 6. True or false? True, right? So we shaded the right region. So anytime you do one of these, go back to the original, stick in 0, 0. If you get a false statement, then 0, 0 should not be in the shaded region. You get a true statement, and you can take any other point, right? I can take a point like 1, 0. So 2 minus 3, negative 1 is less than or equal to 6. Yeah. Okay. Any point that's in here makes this a true statement, right? Because we are graphing an inequality, which means half the region is shaded and half. You know. And by half, it's only because it's an infinite plane. Graph 3x minus 2y is less than 12 using x and y intercepts and a test point. So the thing is, if I don't put this into slope-intercept form, then I really don't know. Like here, I know which way to shade, right? Greater than or equal to, less than or equal to. If I'm going to graph this using x and y intercepts and a test point, then I'm going to have to graph the bounds. So first we're going to graph the intercepts. Okay, so x-intercept, set y to 0. What does that give us? 3x minus 2 times 0 is less than 12. Again, let's just graph this as equal to 12, right? Because we're going to graph the line. So 3x equals 12, x equals 4. Okay, that's the x-intercept, right? So we're switching back to, I need to find these points, right? And the y-intercept, set x equal to 0. again, go with the equality. So it's 3 times 0 minus 2y equals 12. Negative 2y equals 12. Y equals negative 6. Now, what kind of line? A dashed line or a dotted line, right? So not a solid line. Okay, it can't be solid. Solid says we're including the boundary. This says that the region I want is strictly less than 12. So it can't include the line because the line is where it will be equal to 12. Okay, so blue, what were the numbers? 4 for the x and negative 6 for the y. So 4 for the x, negative 6 for the y. I'm going to draw a dashed line. And it's going to extend. Now, where do I shade? Yeah, and I'm not really sure, right? Like, I don't know which region to shade, so a test point. So what test point might we want to use? 0, 0. I love 0, 0. Okay, so that gives me 3 times 0 minus 2 times 0 is less than 12. 0 is less than 12. Is that true?
Yeah.
So then, which way do I shade? Above or below? Got to include this point. I got to shade above. It's just ugly when you shade on this thing.
Oh
Right?
my god.
I know, eh? Get rid of those last couple of scribbles. They're making my eyes go funny. You got pencils you can shade nicely. It's when an HB pencil is nicer than a mechanical pencil, right? And put it on edge. If you're good, you can have little shadows in there.
That was not
You have the wabbit emu sitting there. Yeah. Okay, so what's important? Solid line or dashed line, arrows on the end of the line, and which way you shade it. Okay. Always double check with a test point, whose name is probably 0, 0, unless 0, 0 is on the line, right? Then you're gonna have to pick something else. But it's pretty easy to pick. It's pretty easy to pick a point, right? I mean, you always pick the point. Hey, what about negative 6, 0, right? Like, or sorry, 0, negative 6. Is that true? No, it's false. Okay, then this better not be shaded. When sketching an inequality that has a symbol greater than or equal, draw a what kind of line when it's greater than or equal to? A solid line. And when sketching an inequality that is strictly less than or strictly greater than, draw a dashed line. Okay, so it's difference between solid line and dash. Okay, everybody good on this concept? Right? One or two of these on the test. Write an inequality in the form ax plus by is less than or equal to c that represents the graph shown. And, okay, so somebody graphed this. So, what do we got? 6 and 8, right? Okay, what do we need to get the equation of a line? What must you have? One piece of information you must have. You must have this before you get the equation of a line. It goes by one of the letters in y equals mx plus b. What must you have?
or y. X. B.
Slope. You gotta have m. Yeah.
And
Okay, the y and. Thank you. We got 3 wrongs before we got the right, which was So you need the slope. What's the slope of this line? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So which way did it go? Down 6, right 8. Okay, so what's the equation of this line in slope y-intercept form? So let's write it as y equals. Y equals what? Negative 3/4 x
What's that? 6.
plus 6. Okay. After the slope, what else do you need? Then you need a point. If that point happens to be the y-intercept, then life is really easy if you just go into y equals mx plus b, which unfortunately is not what they want from us, right? But wait a sec. That's the line. What's the region? Below it. So that means that y is, what goes here?
Less than.
Just less than, right? Because the line is dashed. So we know this is y is less than negative 3/4 x plus 6. Okay, now we got to write it so that it's ax plus by is less than or, I don't think they meant less than or equal to, right? It's got to be less than, but whatever. Okay, so first step, what should I do to get this in the ax plus by? Times by 4. So we get rid of the denominator, right? So we have 4y is less than negative 3x plus 6. No? Yes, 24. Good, because that's the mistake you guys will make. So I'm making it for you now so you won't have to. I'm saving you the trouble of making that mistake on the test. Now multiply everything by 4, right? Take your time on the thing, right? Okay, you don't have quite as much time. You know, like if you took the whole class through the quiz, you got nowhere near that amount of time to do the test, right? But, you know, just work it carefully. And if you're done early, go back and check things over. Anyways, now what do we got to do? One last thing. Okay, so we got to move the x over, right? It's got to be ax. I like my a to be positive, so which it is because it was a negative 3x. Moves over, becomes positive 3x. Plus 4y is less than 24. Had if that had been a plus 3x and move it over, I have a negative 3x, I would have gone through, multiplied by a negative, changed all of the signs, and flipped the inequality. Okay. But this is 3x plus 4y. Test point. 0, 0. Is 0 less than 24? Then this point is in the shaded region, and it's on that. X-intercept. X-intercept is going to be x is 8, y-intercept 6. Yep. Right? So everything matches. It's all good. Right? Algebraically determine if the point negative 2, 4 is part of the solution. Okay? So how are we going to algebraically determine if the point is part of the solution? We're going to test it, right? We're just going to stick it in there. So we're going to say, all right, 2x. 2x plus 3y is less than or equal to 6. Now in the end, which you're going to work out, so go ahead and do this, you're going to come up with a statement that's either true or a statement which is false. So figure it out. Come up with an answer. Your choices are true or false. Or yes or no. False. Because what do we end up with? Well, we've got negative 4 plus 12 is less than or equal to 6. 8 is less than or equal to 6. And that's not true. So the point negative 2, 4 is not part of the solution. What's that saying? If you're not part of the solution, then you're part of the problem. Well, that's also, it is part of the problem. But it's not part of the solution. See page 470, example 4. Really?
We have to do that.
So 470, example 4, write and solve an inequality. Suppose that you are constructing a tabletop using aluminum and glass. The most you can spend on materials is $50. Laminated safety glass costs $60 per square meter, and aluminum costs $1.75 per foot, because we should mix units like that, right? Which is probably what is actually going to happen in real life. You can choose the dimensions of the table and the amount of each material used. Find all the possible combinations of materials to make the tabletop. Well, it's okay. What it means is find a region, right?
Oh,
It means that obviously I can't use 1 square meter of glass, right? Because that's $60 and then I'm over my budget. So at the most I can use, right, that would be our intercepts, right? So whatever we choose. So let's see. Let X represent the area of glass used and Y represent the length of aluminum used. Okay, then we get this equation. So 60X plus 1.75Y must be less than or equal to 50, right? So if I choose Y as 0, I don't know aluminum, it's going to be glass, then it's 50 divided by 60 square meters of glass, right? And if I choose all aluminum and no glass, then it's going to be whatever. Okay, so we could find those intercepts, right? Solve the inequality for Y in terms of X. Okay, so we want to write this as Y. So go 1.75Y is less than or equal to negative 60X plus 50. And Y must be less than or equal to negative 60 over 1.75X
it's really weird.
plus 50 over 1.75. Yeah. Weird numbers, but you know what? We're just going to enter this into our calculator, right? We're going to go to Y equals, I don't care that it's negative 60. Yep. Yep. So let's go bracket negative 60 divided by 1.75 close bracket X plus 50 divided by 1.75. Okay, cool. Let's figure out a window. So X probably between 0 and 1, right? Because 1 is going to take it to 60 and that's out of the region. So window, let's say my X values go from 0 to 1, maybe by 0.1s. And the Y values, $1.75, call that $2, it'd be 25. So let's go a little bit more, maybe up to about 30. What's 30 times 1.75? 30, and I think it's over 50. So. Okay, Y, let's go from 0 to 30 by 5. Let's graph that. Perfect. Now, if I didn't hit here or here, then I could adjust my window, right? So if I had a line that was coming down and was sort of, I went here and it just sort of cut off there, then I would just say, oh, I better extend my X values, and then same with Y values if I didn't quite go there. Now, on your calculator, now we need needs to be less than or equal to. So on the calculator, we can do this, I think. Let's see what happens. Color blue. Okay, I'm going to say OK. And the line. So that's above, and I want to shade below, right? And I'm going to say enter OK. This is fancy on the color one, right?
Yeah.
For yours, just arrow over to here and keep hitting enter until you see it going shade below, right? And then there you go.
Oh, holy moly. This is really messed up.
Okay? So any point in this region satisfies the inequality, right? I can use any point. From all X, from all glass to all aluminum, but I'm probably going to want to be somewhere in here and close to the line because I want to spend the $50, right? I mean, I'm not going to cheap out and say, well, let's not make one, right? That's the easiest, 0, 0. Okay. And I'm not going to make a really cheap one. So anything that's on the line will be your most expensive, but anything in that region satisfies the inequality. Okay? Good.